United States Coast Guard spent this past weekend investigating reports of
This weekend, the Florida Department of Health in Manatee County is warning beachgoers to steer clear of the water at certain beaches.
A sudden surge of activity beneath the Pacific Northwest has sent shockwaves through the scientific community. In a region already known for its volatile geology, new satellite images have unveiled a network of underground magma tunnels that may link three of the most dangerous volcanoes in the United States: Mount Rainier, Mount St. Helens, and Mount Hood. These revelations are not just scientific curiosities. They carry serious implications for millions of residents and the broader stability of the region. Geologists are raising alarms and calling for immediate action as the signs point to a potentially coordinated volcanic system that could change the landscape in catastrophic ways. The discovery has transformed what was once considered isolated volcanic threats into a more interconnected and potentially explosive scenario. The Pacific Northwest forms part of the geologically active Ring of Fire, a massive horseshoe-shaped belt around the Pacific Ocean where tectonic activity is particularly intense. It's a region that has experienced its fair share of eruptions and earthquakes, but the possibility that Rainier, St. Helens, and Hood are connected by deep magma channels was previously just a theory. Now, with the help of advanced satellite imaging and seismic monitoring, scientists believe they've found concrete evidence supporting this hypothesis. The images reveal anomalies consistent with molten rock moving deep beneath the surface, aligning along fault lines that trace a rough path between the three volcanoes. This subterranean activity has sparked concerns that pressure is building within a shared magma source, increasing the risk that an eruption at one volcano could influence the others. Mount Rainier, towering over 14,000 feet, is often considered one of the most dangerous volcanoes in North America. Its massive glacier cover and proximity to densely populated areas like Seattle and Tacoma make it a unique threat. If Rainier were to erupt, the combination of lava, ash, and rapidly melting ice could trigger lahars, deadly mudflows capable of racing down valleys and burying entire towns. Mount St. Helens, to its south, famously erupted in 1980, killing 57 people and flattening over 200 square miles of forest. Since then, it has remained active, with intermittent steam emissions and small earthquakes keeping it under constant observation. Mount Hood, Oregon's tallest peak, also shows signs of volcanic activity, though it hasn't had a major eruption in over 200 years. Despite its relatively quiet demeanor, Hood remains capable of erupting with little warning. Each of these mountains poses a risk on its own. But if they're indeed connected by magma tunnels, as recent data suggests, the danger escalates significantly. A disturbance in one could destabilize the others. For instance, increased magma pressure beneath St. Helens could, in theory, travel through these tunnels and trigger unrest beneath Rainier or Hood. This cascading effect is particularly concerning because it could overwhelm emergency management systems and reduce the time available for evacuations. Scientists are now re-evaluating old assumptions, realizing that the interaction between these volcanoes might have been underestimated for decades. The use of satellites has revolutionized how geologists monitor volcanic systems. Instruments capable of detecting subtle ground deformation have shown that the surface near these volcanoes is bulging, an indication that magma is accumulating beneath. In addition to visible changes in the terrain, satellite sensors also detect thermal anomalies or sudden increases in ground temperature, which can signal rising magma or gas releases. Over the past 6 months, such anomalies have appeared along a curved path linking the three volcanoes, further reinforcing the idea of a connected system. Combined with ground-based seismic data, the case for interlinked magma chambers becomes increasingly compelling. The implications of a connected volcanic system extend beyond local communities. An eruption involving more than one volcano, or even a rapid sequence of individual eruptions, could disrupt air travel across the country, damage critical infrastructure, and affect agriculture through ash fallout. Major highways, rail lines, and power grids crisscross the region and would be vulnerable to ash accumulation, lahars, and landslides. Furthermore, the economic impact would be felt nationwide. The region is home to major ports, tech companies, and supply chains that are integral to the U.S. economy. A prolonged volcanic crisis would not just be a natural disaster, but a significant national emergency. The scientific community is calling for urgent investment in expanded monitoring and early warning systems. While current technology allows for the detection of magma movements and ground deformation, the coverage is still incomplete. Many remote areas between these volcanoes lack real-time sensors, leaving blind spots in a region that cannot afford them. There are also calls for increased public awareness and education. Many residents of Washington and Oregon remain unaware of the risks posed by these volcanoes or the steps to take during an emergency. Emergency preparedness drills, improved evacuation routes, and clearer communication from authorities could save lives when minutes matter most. Federal and state agencies have begun holding emergency meetings to coordinate responses. The U.S. Geological Survey, FEMA, and local emergency management offices are reviewing worst-case scenarios and updating response plans. Simulations based on recent data have shown that even a moderate eruption could trigger massive displacement and strain public services beyond capacity. Hospitals, shelters, and transportation systems would all face immediate stress. Coordination between agencies is key, especially given that these volcanoes span different states and jurisdictions. It's a complex logistical puzzle that must be solved before the ground starts shaking in earnest. One of the biggest questions now facing geologists is whether this interconnected system is a new development or something that has always existed. Some researchers believe the magma tunnels may have been dormant or less active in the past, only now becoming visible due to technological advances. Others argue that we are simply witnessing a natural cycle, one that has played out over millennia, but went unnoticed due to the limits of past science. Regardless of its origins, the reality remains that the threat is growing, and ignoring it is no longer an option. Interestingly, there are historical accounts from Native American tribes that suggest they witnessed multiple volcanoes erupting in close succession, perhaps hinting at a shared system long before modern science confirmed it. These oral traditions, passed down through generations, often speak of fire, ash, and rivers of mud flowing across the land. Some geologists are now revisiting these stories with fresh eyes, considering them as potential early records of a similar event. If those stories do in fact reflect a real chain reaction of eruptions, it would add weight to the current theory and underscore the urgency to prepare. While no one can predict the exact timing of an eruption, all indicators point toward heightened activity in the region. It's no longer a question of if, but when something might happen, and whether we'll be ready when it does. This isn't just a geological story, it's a human one, involving millions of lives, entire ecosystems, and vast economic systems that depend on the stability of the region. The responsibility now falls on authorities, scientists, and communities to respond to these warnings before it's too late. The interconnected nature of these volcanoes also raises new questions for long-term planning. Should communities be relocated from high-risk zones? Are current building codes sufficient to withstand ashfall or ground shaking? Is our power grid resilient enough to survive a prolonged volcanic crisis? These are not hypothetical concerns. They are immediate, practical questions that must be addressed if we are to avoid a future disaster. With climate change already putting pressure on natural systems, the addition of volcanic instability could tip the balance in unexpected ways. The time for passive observation has passed. We are standing on a potentially volatile fault line in more ways than one. The discoveries made by satellites and seismic tools are not just academic, they are urgent signals demanding action. As scientists continue to study and map the underground networks that lie hidden beneath our feet, one thing is certain: we are dealing with forces far more complex and interconnected than previously thought. And while we may not be able to stop what lies beneath, we can at least prepare for it. If you found this breakdown of the latest geological developments insightful and want to stay informed about future updates and major discoveries, make sure to like this video, share it with others who need to know, and subscribe to the channel for more deep dive analysis on global events that matter.